Okay, welcome to lesson 23. The title of this lesson is the defining equation of a line. And what we're going to see in this equation is that seemingly different equations can graph as the same line. So we're going to do some exercises and then I will show you a theorem. Okay, so these first exercises, if we were in class, we would do them all together and be discussing them. But as it is, I'm going to have you work through exercise 1 first. And if you feel comfortable, and you should, we're not really doing anything different here as far as graphing and manipulating equations to change them into different forms. So you should be comfortable. You might skip a couple questions, but see if you can get through exercises 1 through 3. If you have someone to work with, that would be great. Otherwise, you can just work through the problems on your own and then come back and we will begin to look at this together and compare notes on what's happening. You are going to need graph paper for a few of these, so make sure you have some graph paper on the side to do that. Okay, go ahead and pause the video and start working. All right, so for exercise 1, we are asked to sketch the graph of the equation 9x plus 3y equals 18 using intercepts. So we'll practice that. And then answer parts A through F that follow. Okay, so let's start by looking at what those graphs look like. And I've put them up here, so I'm going to color code my lines here. So we've got in the green above 9x plus 3y equals 18. And we're going to graph that using intercepts that we have seen before. So using intercepts, I'm going to find the x-intercept here where the equation crosses the x-axis. I would put in 0 for y and then solve for x. So if we put in 0 for y, that term kind of goes away. So I have my arrow over it. And I see I have 9x equals 18. Divide through by 9 and I get x equals 2. So x equals 2 is a point on my graph. Let's see if, I need this dot tool. And we can go ahead and plot it. Right there, roughly. Okay, so that would be the x-intercept. So now let's look at this equation again, and if we cover up this, because putting in 0 for x is going to tell me where this line crosses the y-axis. So I'm going to put in 0 for x, and I get 3y equals 18, so y must equal 6. So the point 0, 1, 2, 3, 4, 5, 6 is on the graph of our equation. Okay, so there are the intercepts and there's the graph that that defines that line. Okay, so now we want to graph the other equation. It is in our slope-intercept form, which is nice. So we can get our starting point by covering up this x term. Because when x equals 0 is the y-intercept, so x equals 0, 0 times negative 3 is 0, y equals 6. So the first point we have is 0, 6. So I get my purple dot here and put it right there. And then our slope is negative 3, so that would be over 1. Whoops. Okay. over 1 down 3, over 1 down 3. So we've got our slope of -3, and it's giving me all the points that are on the line. So I'm noticing that this is kind of odd. So that was a point, not that one, and that one are all points. So what we're finding is that these two equations actually graph as the same line. So we say they define the same line. So let's go back to our exercise and answer some questions here. So you have this in your notes. I know it's probably pretty hard to read on the screen. What do you notice about the graphs of 9x plus 3y equals 18 and y equals -3x plus 6? And why do you think this is so? So hopefully you wrote something to the effect of they are the same line. And why do you think this is so? You might have said a lot of different things, and we'll talk more about that as we go along. So what we want to do now in part C is rewrite y equals -3x plus 6 in standard form. So to do that, I would, well, I guess I should write it bigger. Y equals -3x plus 6. So what I would start with, and hopefully what you did too, would be to add 3x to both sides. So if I add 3x here and add 3x here, I'm going to end up with the equation 3x plus y is equal to 6. 3x plus y equals 6. Identify the constants a, b, and c of the equation in standard form from part C. So the constants are a equals 3, b equals 1, and c equals 6. And then we're asked to identify the constants of the equation 9x plus 3y equals 18 and call them a prime, b prime, and c prime. So let's see, I'll try to write it over here. A prime is equal to 9. B prime is equal to 3. And c prime is equal to 18. Okay, so let's move on and look at another example here. So what we're going to be looking for are some patterns here, and you might already be noticing the patterns. Okay, there's our equation. What happened to that? And let's do another one. So here in number 2, we're asked to graph the this equation in slope-intercept form, y equals 1/2 x plus 3, and then the graph in standard form we'll graph using intercepts again. So here's our equation. So let's first graph the one in slope-intercept form, the purple graph. So we have a y-intercept of 3 right there. And we've got a slope of 1/2. It's positive 1/2. So that would mean I'm going to use that to get my next point. So we're going to go a distance of 2 in the horizontal direction and up 1 to get our next point. And from that, we could graph our line. So our line is going to come through here, something like that. Okay, so there's that line, and then let's use green to graph the equation in standard form. 4x minus 8y equals negative 24. So we'll use what we know about intercepts. So let's let x be 0. That will give us our y-intercept. So we have, if x is 0, this term drops out. We have negative 8y equals negative 24. So y is 3. So we can graph y equals the point 0.03 is our y-intercept, and it's the same as the previous equation. Okay, so if we let y equal 0, then this term drops out, and we're left with 4x equals negative 24. So we get the point, I hope it fits on my graph, divide through by 4, x equals negative 6. So we'll use the green dot and go negative 6 on the x-axis for y equals 0. And then let's graph that line with a green line. Okay, and we'll get this line coming right through. Let me try that again. Okay, so I think I finally got it. So there is the graph of the green equation. So once again, our two equations are defining the same line. So they're in effect the same equation. So let's go back and look at the questions for this one as well. So we've sketched them. We've noticed that they are the same line. I'm not writing very much. You should write a little bit more. Why do we think this is so? Well, we think they're probably the same equation in a different form. So let's look, let's rewrite y equals 1/2 x plus 3 in standard form. So I would like to multiply both sides of this equation by 2 to get rid of that fraction. And I'll get, in fact, I'm going to just be tricky and multiply by negative 2. And so, and maybe you'll see why. Negative 2y is equal to negative x. And don't forget to distribute this 2 to both terms in here. Number one mistake on these. And this will be minus 6. Okay? And so now I would like to add x to both sides of my equation. And I will get a new equation, and I'm going to write it in standard form. X minus 2y is equal to, and then the negative x and positive x become 0 together. I'm left with negative 6 right here. So I've got x minus 2y equals negative 6. And part D says, what are the A, B, and C of our original equation? A equals B equals C equals. And we have, let's go back and look at what it was. We have A is 1 right here. A is 1, B is negative 2, and C is negative 6. So we've got 1, negative 2, and negative 6. And we're going to call the coefficients of the second equation that we're saying we think is just in a different form as 4, negative 8, and negative 24. 4, negative 8, negative 24. And then we're asked, this is different from exercise 1, to look at these ratios. What is the ratio of a to a prime, or a prime to a? So let's look at that. A prime over a is equal to 4 over 1, which is 4. B prime over b is equal to negative 8 over negative 2, which is also 4. And c prime over c is equal to negative 24 over negative 6, which is also equal to positive 4. So all three of these ratios of the coefficients of our equations in standard form, we're noticing are the same value. So a times 4 gives me a prime, b times 4 gives me b prime, and c times 4 gives me c prime. Okay, so it looks like we're discovering something here. All right, so let's look at another one of these exercises. So exercise 3 says that the graphs of these two equations, y equals 2/3 x minus 4 and 6x minus 9y equals 36, are the same line. So we're not asked to graph this one. They're just telling us they're going to graph as the same line. So we want to rewrite y equals 2/3 x minus 4. Rewrite that in standard form. So let's get rid of that fraction, and by multiplying both sides of this equation by 3. So I'm going to get 3y is equal to 3 times 2/3 is 2x minus 3 times 4 is 12. So now I want to subtract 2x from both sides, and I'm going to continue that up here, right up here. And so I will get negative 2x plus 3y is equal to negative 12. And now remember, in standard form, we don't want that negative sign on the a coefficient. It has to be non-negative, the coefficient of x. So we're going to multiply everything through by negative 1. Now remember, in that last step, in that last transformation in number 2, I just multiplied through by a negative number to start with, because I knew I anticipated that I was going to need to. So I could have multiplied here by negative 3, which would have given this a negative term, and then I saved myself that step. But it's not a big deal. So what do I have? When I multiply all these terms by negative 1, I get 2x minus 3y is equal to positive 12. Okay, so what are the coefficients a, b, and c of my the equation in standard form from part A? The coefficients would be 6, negative 9, and 36. And the constants, oh, never mind, they want the other one. Okay, I thought so. Okay, so the standard form of the slope-intercept form will be our ABC. And so those were 2, negative 3, and 12. And then these other constants, a prime, b prime, c prime, are 6, -9, and 36. Okay, so remember that. We'll go to part D. Part D is going to ask us, what do you notice about those ratios of A prime over A, B prime over B, and C prime over C? Move that one away a little bit. So let's go and put those numbers in here and see what those are. So A prime over A would be 6 over 2. 6 over 2. And then B prime over B would be -9 over -3. And then C prime over C would be 36 over 12. Okay, so each one of those ratios has a value of 3. Okay, and so it says you should have noticed that each fraction was equal to the same constant. Multiply that constant by the standard form of the equation from part A. What do you notice? Okay, so here was our standard form. If we multiply this entire equation by that constant of 3, we're going to get the equation 6x, 3 times 2x is 6x, minus 9y is equal to 36. 3 times 12. So this equation exactly matches the other one that it graphed like. Okay, so we have a theorem, and the theorem says suppose you have these constants a, b, c, a prime, b prime, c prime, and at least one of a or b and a prime or b prime are non-zero. If you have that situation, then one thing can happen. Two things are true actually. The first one's this: if there is a number s such that a prime equals s times a, b prime equals s times b, and c prime equals s times c, then ax plus by equals c, and a prime plus b prime, a prime x plus b prime y equals c prime define the same line. Okay, so that one is saying if we can find that number s, if there is that number s, then those equations define the same line. And likewise, if the graphs define the same line, then there exists a number such that that's true. So it's kind of the backwards, right? So if the graphs define the same line, then there's this number s such that everything's a multiple of, they're multiples of each other. Okay, so let's see if we can see how that works out in some problems. Okay, so how would we, let's look at exercise 4. How would we write 3 equations whose graphs are the same line as the equation 3x plus 2y equals 7? So try that on your own. I'll give you a hint. There's lots of ways you could do this problem. So try it on your own and then come back and see my solutions. Okay, so if I'm going to find three equations whose graphs are the same line, I'm going to start with the original equation and just multiply the whole equation by some number. And so I'll pick 2. So my first equation would be 6x plus 4y is equal to 14. So those two, all the coefficients are just double. I could do the same thing. I could make them triple. So I could come up with 9x plus 6y is equal to 21. All right. And then I could even multiply them all through by 10. So I could have 30x plus 20y is equal to 70. Okay, so there you have it. So yours are correct if you took the original equation and multiplied by different numbers. Okay, all right, so what are three equations whose graphs are the same as x minus 9y equals 3/4? Okay, so I want to get rid of the fraction, so I'm going to multiply by 4. So I'm going to get 4x minus 36y is equal to 3. Okay, and now this equation's actually in standard form. It wasn't before because in standard form you can't have c being a fraction or a or b. So now I could take and multiply this equation by 2 and get 8x minus 72y is equal to 6. And I could multiply that one by 2 again. Or how about if we multiply it by, it doesn't say they have to be in standard form, so I could multiply it by -1. So I could get the equation negative 8x plus 72y is equal to -6. All right, so there's my three equations. Yours could be different. Okay, write three equations whose graphs are the same line as this equation given. I'm going to start by multiplying through by -1. So my first equation is going to be 9x minus 5y is equal to 4. Every term got multiplied by -1. So there's my first. Then I will multiply through by 2. Not particularly creative here, but it works. Okay, and then let's multiply them all by 10. 180x minus 100y is equal to 80. Okay, so these four equations, this one and the original, will all define the same line because they're just the same equation multiplied. Okay, so exercise 7's a little different. Write at least two equations in the form ax plus by equals c whose graphs are the lines shown below. So you're going to get a little practice here writing the equation of the line like we did in the last lesson. So let's look, let's find some good points, and I find one here and here. So I know I need to start by finding the slope, And the slope here, I'm going to do it from these 2 points. I can see that the slope is 1 over 4. Okay, slope is 1 over 4. I could have done that with coordinates. The coordinates of these points, 0, 3, and -1, -1. Could have found the slope that way. It would be the difference in y, 3 minus -1, over the difference in x, which is okay, so see how easy it is to make a mistake here. Just write the coordinates of a point wrong and you'd be in big trouble. So this is the point 3, 0, not 0, 3. So let's try this again. Okay, so the slope is the difference in the y, which is 0 minus -1, over the difference in the x, which is 3 minus -1. So my slope here, 0 minus -1 is the same thing as 0 plus 1. So this is 1 over 3 plus +1, which is 4. So our slope is 1/4, as we can see from the graph. Okay, so now I need to still find the equation of the line. And I like using the slope-intercept form to do that. So I know now I have y equals 1/4 x plus whatever my y-intercept is, which I know is between 0 and -1, but I can't tell exactly what it is. I'm going to put in one of my points, so I'm going to choose this 3, 0. So in that point, it's a known solution to this equation. The y is 0, so 0 equals 1/4 times 3 plus b. So I have 0 equals 3/4 plus b. So you can kind of see here that b's got to be the opposite of 3/4 to make those two numbers add up to 0. I can also subtract 3/4 from both sides and see that -3/4 is equal to b by subtracting 3/4 from both sides. So I have the equation of this line. So I know that this line is y is equal to 1/4 x minus 3/4. And I want two equations in the form ax plus by equals c, whose graphs are this line. So I need to at least put this in standard form. So let's multiply through by 4. I'm going to get 4y is equal to x minus 3. So subtracting x from both sides gives me -x plus 4y is equal to -3. And to get it in standard form, I need to multiply through by -1 to get x minus 4y is equal to 3. Okay, so there's my first equation in standard form, whose graph is the line shown. I can multiply that equation through by 2 and get 2x minus 8y is equal to 6 for another equation that will graph as that same line. Okay, so let's look at 8. So write at least 2 equations in the form ax plus by equals c, whose graphs are the lines shown. Okay, so once again we want to find some nice points for finding slope, and I find a couple right there. This is a negative slope, right? So we'll make sure we get that in our, so I know this slope is going to be negative, so I'm just going to write it right off the bat so I don't forget. This distance is 3 and this is 4. Okay, there's another point down here. Okay, so that means my slope is the vertical change, or the change in y, over the change in x. So this slope is 4/3 and it's negative 4/3. Okay, so once again I don't know my y-intercept, so I'm going to try to find it. So I could use, I'm going to show you again another example of how I can use a different form of the equation of a linear equation in 2 variables to do this. So remember we had that form that was m times x minus x1 is equal to y minus y1. And we noticed that that was really just the slope formula. So if we took this x divided by x minus x1, I would just have the formula for slope reorganized. So that's what we have going on there. But I can put in my known points and solve for and write my equation. So I'm going to use this one. So I've got the point -1, 2, and I'm going to use that for x1, y1. So I know my slope is -4/3 times x minus x1 is -1. So that's going to be minus a -1 is +1. And that's equal to y minus the y1 coordinate, which is 2. Okay, so I've got -4/3 times x plus 1 equals y minus 2. So I think I'm going to multiply through by 3 now on both sides. Show that in purple to get rid of that fraction. So I'm going to multiply this side, both sides by 3, and the result will be I've got -4 times x plus 1 is equal to 3 times y minus 2. Okay, now I'll use the distributive property and get my terms here. So I've got -4x minus 4 is equal to 3y minus 6. Okay, now I want to get these constants together here, so I'm going to add 4 to both sides. This might be a little bit longer process than using the slope-intercept form. -4x is equal to 3y. -6 plus 4 is -2. And now I'm going to subtract 3y, so I'll have -4x minus 3y is equal to -2. So I just need two equations in the form ax plus by equals c. So this actually needs to be multiplied through by -1, and we'll get 4x plus 3y is equal to 2. Okay, so 4x plus 3y equals 2 is one equation in standard form that defines that line. I'm going to write another one just by multiplying by 3. So I'm going to get 12x plus 9y is equal to 6. And there's my second equation in standard form. Okay, so we are done. So here's your lesson summary. Basically what we realized is that there are lots of equations that can define the same line. But we notice some patterns between them when we take the slope-intercept form and put it in standard form. We notice that those equations in standard forms are just multiples of each other if they define the same line. Okay, so I'm going to, because we didn't really do the proof of this, number 4 and number 5 you can leave off. So work on numbers 1, 2, and 3. So that shouldn't take you too long. And we will see you back for lesson 24.